Hi guys, it's your boy Mr. Tsebi and then welcome to Linear Algebra Maps Part 3. So this is Part 3. So suppose that we are given a problem like this and then they say that let L maps from second dimension all the way to third dimension be a linear map. So they already told us that this is a linear map such that L1 and 2 equals to, sorry, this is L1 and 2 equals to 101 and L2 comma 5 equals to 0 1 and 1. What is the value for L01? So this is the thing that we want to compute. So but we can say, we can take this value of L and we say not 1 equals to a multiplied by this 1 comma 2, and then we can add it by b multiplied by 2 comma 5, 2 comma 5. But the formula for us to find a, this is, I can just call this a and then this is b, and then I can, or let me just call it x and y, x and y, x and y. So the formula to find a, I formulated a formula. So for us to find a, we say y plus x all over 2. And then for b, we say x minus y all over 2. So let's find the value of a. But we are going to compute it using what we are given, which is 0, 0 and 1. So we can compute it. But what is our x? A 0 and 1 equals to, what is our y? Our y is 1. And what is our x? Our x is 0 divided by 2. This is just 0.5. So my value of a is 0.5 here, 1.2. So what is my value for b? My value for b, according to our formulas, b of 0 and 1 equals to x. But what is my x? My x is 0 minus 1 all over 2. This is my x. So I'm going to get 0.5. So this would be 0.5, 2.5, like this, like that. So let me erase this part, just like that. So since we are here, we can say that, okay, our L01 equals to what? Equals to 0.5. Remember, 5 is a scalar, which is 1, 2 plus minus 0.5 L 2.5. I'm introducing L to our equation. So, but what is this? What is this? 0.5 L 1.2 is the same as what? L 1.01 plus, look at this guys, minus 0.5. But what is L 2.5? 0, 1 and 1. 1 and 1. That is our L. So let me erase here. Let me erase this part. So since we are having this, I can just bring it here. L01 equals to 0.5, 1 and 0 plus minus 0.5, 0, 0.1 and 1. Let us us not forget, yes. If I multiply through the brackets, I'm going to have 1 over 2, and here I'm going to have 0 with this one. Okay, sorry, it's comma 1, something like this. Something like this. So if I multiply by 0.5, I'm going to have 1 over 2, and then here I'm going to have 0, and then when I multiply this and this, I will just have 1 over 2 plus. If I multiplied this by this one, I'm going to get 0, and then here I'm going to get 1 minus 2, and then there I'm going to get 1 minus 2. So if I add 0 plus this one is the same as 1 over 2, and then 0 plus that one the same as 1 over 2, and then this and that one is the same as 0. So this is our L0, 1. So let's take another example based on this one. Suppose that we are given an example and they say let T R all the way to R squared be a linear transformation. T means transformation, such that T 1 and 1, 0 and 2, and T 1 minus 1, 2 and 0. Find T 1 and 4. They've given us something like this. So they are saying we should find this one. But this can be written as 1, 4 equals to A. I'm going to take this part. 1 and 1 plus B 1 and minus 1. But what is my A? Wherever where I see A, I can just put on my formula because of I know it. This is my formula for A. And then wherever where I see B, I can just say this is my B, but of this one. So what is my Y? My Y is 4. And what is my X? My X is 1. All over 2, 1 and 1 plus. What is my X? My X is 1. What is my Y? Is minus 4 all over 2, 1 and minus 1. So 1, 4. So if I invent T, I'm going to have 1 over 4, which is equals to 5, which is 2, 5. 2, 5, 1 and 1 plus, this 1 and 1 here will become, because of I'm inventing T, it will be T1 and 1 plus. This one will be minus 1, 5. T1 and minus 1. So this is the same as 2, 5. But what is this part? T1 and 1 is 0 and 2. And then what is this part? T1 and minus 1. It's just 2 and 0. It's just T2 and 0. I can erase this part. This information is now useless since we have our final equation. So I can see that my T1 and 4 is the same as 2,5 times 0, it will be 0. And then 2,5 times 2 is 5. Plus minus 1,5 times 2, it's minus 3. Minus 1,5 times 0 is just 0. So 0 plus this one is minus 3. 5 plus 0 is 5. So we are done for 1 and 4. So this is the value for 1 and 4. Let's pick one last example. One last example. It says, let T map from second dimension all the way to second dimension. Be linear transformation. T, like I said, is transformation such that T1 of 1 equals to 9,2 and T1 and minus 1 equals to T and 0. So now they want us to find T minus 2 and 1. This is what they want us to find. That's what they want us to find. So we can start with what we know, which is minus 2 and 1, which is the same as A multiplied by 1 and 1 plus B multiplied by 1 and minus 1. So my A is what? It's y plus x over 2, 1 and 1. And then my B, according to our formula, it's x minus y all over 2, 1 and minus y. So this is 2 and 1. So if I invent T in this side, it means that what is our y? Our y is 1. But what is our x? It's plus minus 2 all over 2, which is 1 and 1. Let me not rush it this time. So, but what is my x? It's minus 2. Minus, what is my y? Is 1 all over 2, which is 1 and minus 1. So, this is the same as 0,5. But since I'm inventing T in this side, I must also invent T here, which will be T1 and 1. Plus, this will be minus 1,5. 1 and minus 1. But what is T1 and 1? T1 and 1, it's 0,2 plus minus 1,5. Oh, sorry guys, even here we must also invent T, since we invented T there. So we must also invent T. So, but what is T of 1 and 1? Is the same as 2,0. So let me erase the first part. So T of minus 2 and 1 is the same as minus 0,5, 0,2, minus, oh sorry, plus minus 1,5, 2 and 0. According to our formula, guys, we must add. Always never multiply this and this one. This negative must be in the brackets. So when we multiply this and this one, we just get 0. And when we multiply this and this one, when we multiply this and that one, we just get minus 1. When we multiply this and that one, we get minus 3. and then there we get 0. Minus 3 and 0, minus 3, minus 1 and 0, minus 1. So that is the value of minus 2 and 1. So guys, this is the end of the of our video. If you enjoyed, please subscribe and hit the notification bell, and also don't forget to throw your like and a comment, and also facilitate the link throughout so that your mates can also see it, and so that we can be able to do linear algebra without any difficulties. Thank you guys.